Hi, can you hear me?
Yes.
Cool. Thank you for joining. I'm going to wait for some time to let everyone in and then we'll start. So right now we have just four participants. I think I have already pinged on Slack, but if you happen to know anyone from your own team, please let them know. I'm not sure how many of you have checked the message. There was a poll. We decided that we'll do the office hours on Tuesday from 4:30 to 5:30. So I will have to wait for everyone to join. Okay, so I don't know what the issue is. The Slack message was sent out on Sunday, but there's very few of us. I just sent out an email. Let's wait for another couple of minutes. Otherwise, we'll start anyway. So what you could do in the meantime is just open the same code again. I'm going to share the link again. We will continue in the same notebook, but uh, the link is in the chat box. The link to the notebook is in the chat box. Please open it in Google Colab. We basically want to finish writing the code as much as we can today, so that when we start with the next session, the classroom session on Thursday, uh, we start interacting with the environment and we start thinking about which algorithms we can um, implement to solve this problem. Okay, so I think we will have to start because there's very little time today. So I'm going to share my screen, and I just shared the link to the notebook that you need to open. Right? Can you see my screen now?
So your link is not GitHub path, is it? Okay.
Yeah. Yes. So the GitHub link is in the chat. I'm pasting it again. But if all of us have the notebook open, then let's get started. I think we were at step 2, right? This is where we had to implement this method deserialize, and I was trying to explain what deserialize stands for, what exactly we need to do. So let me know if you're facing any issues. Right? So if you're looking at my screen, this is the version of deserialize that we have to finish, right? And what deserialize essentially is meant to do is that we had a description of the environment over here. We had a few variables. So it's supposed to take this description, which is made up of strings and list of strings, and then convert it into some sort of an internal representation where we can manipulate things, move around the ball, and print things, right? So if you look at the to-dos, uh, there is a bunch of variables that need to be set here. We need to set the number of rows, the number of columns, the number of states, and we also need to set a map variable, which will be the entire field, right? This map variable should ideally be a numpy array. So the map we have over here, which we are calling array now, it is a list of list. We want some sort of a conversion to happen here, so that this is a numpy array. Uh, then we just want to store some of the strings as they are. So agent representation, this is string over here, agent representation. This should be just the string that we pass, that we are using for representing an agent, and then same for opponent, and then same for goal representation, right? But really, sort of the most important part of the code is over here. Okay, so there are three variables that we want to set. One is the initial state variable, one is the goal state variable, and then there is a list which corresponds to all the opponents, the state of the opponents, right? The initial state variable is supposed to capture the initial position of the ball, and that should be a single integer. So the idea here is that we will scan the entire field row by row, and then wherever we find the ball, wherever there is a string that corresponds to this string, right? So we will store that position, but we'll convert it to a single integer, and we already have the helper methods in place to do that. So we have two state which will take a row and column and convert it to a single integer. And then you store that integer in this variable. And then wherever you find the goal state, wherever there's a string that matches with the goal representation, you store that state in this variable. And then because there are several opponents, you need to append to this list. And this is that for loop which is going to scan the entire field. And then within the for loop, there are three different conditions. Uh, there has to be a little bit of correction, right? So this if and elif, they have to be aligned below each other, right? So there are three conditions. The first one checks if we are looking at an agent. So if you are in a position where you have a string stored for the agent, convert that position to a single integer and store that in the initial state variable. And then what we are going to do is we already have converted the entire field into a map variable, right? uh, in NumPy array. So we just want to erase that position. We want to delete the agent from the field because the agent is going to keep changing position. So it's a good idea to store the agent, the position of the agent, and the rest of the field in two different places, in two different variables. So this is what this line is doing, right? So it's basically overwriting the row and column where you had an agent present. But before you do that, you need to capture the position in this initial state variable. And then there is an elif and another elif, which is basically testing if there's an opponent or a goal. And I have already described what needs to happen here. And after the for loop, there are some assert statements which just do some sanity testing, make sure that things are set properly, and then this function is going to return the initial state, right? So I hope this makes sense to everyone. This is what we sort of attempted in the previous session. If everyone already has implemented this, then we can already skip to step 3. But if there are people who still want to implement this, then we can go back to uh, breakout sessions perhaps, and try to implement it today. So let me know either in the chat box or unmute yourself. Let me know if you have already implemented this, because the solution is there in cell 3, right? That is what we discussed. The solution is already there in cell 3. So if you have implemented and if you have understood how this is working, then let's move to step 3. Okay. So I see one message from Sudeep. He's already done. Okay. Sai is already able to implement it. All right. It seems like many of us have done it. Is there anyone who hasn't done it, who still needs some time to implement this step, or any questions about how things are working?
We can continue further. So,
Okay, that's cool. So we'll continue to step 3, right? And do let me know, like, if you were able to implement more steps. If everyone has done that, then we can jump further ahead. Okay. So I see one message where like this implementation is still needed. So what we could do is you can take a little while to implement this code, deserialize, and then the rest of us can take a stab at step 3. Does that make sense?
Yeah, I think it's okay. Let's move on.
Okay, cool. So let's move on. Let's go to step 3. Right. What is the step 3 about? So we already implemented something that converts, that takes a description of the state, the entire field, and it converts it into internal variables, so that we can play a full game, right? In step 3, we have to implement something called set reward function. What is the idea behind this function? So Yeah. So in steps, you basically have to implement the init method, not the set rewards method. So set rewards is already implemented. If you look at the implementation over here, so it is basically doing, it's running a for loop over here. So there is a little bit of testing. So first of all, what is the idea behind set rewards? So we talked about the rules of the game, right? Like if you are in a cell and then you move to an empty cell, we want to penalize that movement because we don't want the player or the agent to wander about the field. So to ensure that the player takes the shortest path, we thought that we would penalize the player every time they make a valid move. So that was one of the rules. The other rule was that if you want to take the ball out of the field, so for example, if you're at the top left and you want to go left, or you want to go further up, then we want to still penalize you with the same penalty of -1, right? And then if you run into an opponent, then there was a penalty of -5. But if you happen to reach the goal state and score a goal, then there was, uh, is there an issue with the audio? Am I audible?
Audible.
Okay.
Okay.
uh, yeah, because I saw one message where there's no audio. Sai, are you able to hear me now? I just need to check quickly because, okay, I think there was some issue with the connection. They have dropped out. But so that was the idea, and rewards function is doing exactly like that, right? So one there is a check over here which basically gives you a warning if you want to reset, because you can call this function at any time, right? But what we don't want is, generally we don't want to change the rules of the game in the middle of the game. So this if condition is basically doing that. But the key part is over here, where you are going through, uh, right? So where you are going through this list called default rewards, which is already being defined somewhere. And then you are basically testing. So when you are trying to override the reward structure, there is a default reward structure that is being set here in it. So anytime you want to overwrite it, we just want to ensure that you have provided all the different rewards, all the different situations. So there should be 4 different keys for unmarked, opponent, outside, and goal, right? That is what this assert is doing. And then this self should be actually outside the for loop. I don't know if anyone noticed this, but this isn't really needed inside the for loop, right? Because you're passing a reward structure, and we just need to capture that and store that in this variable. This for loop is for testing the keys. So if if you just if you're using this code, then this correction is required. You need to move self outside. It won't be visible anywhere, but it's a logical bug, right? So we do have set rewards now, and what we want to do is we want to finish this function, implement this function, init function, right? Now init is the constructor. Init will let you create new objects of this class, right? And sorry, this foosball class. So anytime you want to create a class like this, for example, here, right? This will just invoke the init function. And if you look at the parameters that we are taking, there is a parameter called map, then there's something called agent, then opponent, and goal. And the idea is that these will be strings, or a list of a string representing these things that we have talked about earlier, right? And init is very minimal. It needs to capture the state of the game. It needs to initialize a variable called done, which basically tells us whether the game is in progress or whether it has terminated because you scored a goal or you ran into one of the opponents. So there is a flag called done that needs to be initialized. Then you need to set a list. So actions is all the 4 actions: north, east, west, and south. So you need to initialize that list. Then there is something which is already being done. So init is already calling, and it is already defining default rewards, which I have talked about earlier, and then it is calling the set rewards function that we just saw with these default rewards, right? So I think this is making sense. Okay. Have we been able to implement this part of the code? Cool. Let's try to do that now. So there are just three to dos that we have to cover, and let's see, without looking at the next cell which has a solution, try to attempt it. They We will do that in breakout rooms. So so it shouldn't take a lot of time. Read the description, attempt it, then look at the solution if you really get stuck, and then let's spend like 5 minutes try to do this. This is really short piece of code. I'm opening the breakout rooms. And I really want everyone to, attempt to write the code themselves, because the motivation is that we understand every bit of the code. So please join your respective breakout rooms and try to write code and try to help others if you already figured out. Okay, so it shouldn't have taken a lot of time. I know if you're getting started, then it is a little difficult to understand what exactly is going on. Why are we implementing these methods, and how do they uh, like how do they connect with each other? Which functions call which other functions? That will become evident after we write a little bit of more code. But I just want to understand if everyone was able to at least figure out what will go here. Like, how do you initialize this state? What is the right way to do this? And then this flag and then actions. So did you face any difficulty? Like, did you understand how to do this? And then any difficulty with the code? Okay, so the idea is that, why are we having this variable? We already had a variable called init state, which we initialized over here, right? This init state was captured from the map that we passed to this function deserialize, right? But why do we have a separate state variable? So the idea is that the initial state, the init state variable, will capture the starting state. We want to keep track of that because then we are, from time to time we would like to come back and restart the game. So we want to keep track of that. But the init function, this is again going to be called when you are creating a new game of foolsball, right? So at this point of time, the state and init state, they are both going to be the initial state. And the right way to initialize this will be using a method that we already implemented last time. So the right way to do so will be to call deserialize here. And deserialize, you basically pass everything as it is. So all the four parameters that are sent to init, they get sent to deserialize. Now this is a more more of a question of aesthetics, or writing a readable code than anything else. I could have done all of this inside the init method itself, but then just being able to refactor deserialize out means init is really simple. So there are just four things going on inside init. There is some description that you get from outside. You pass it to deserialize, and deserialize sets some variables for us, and then deserialize also returns us a particular variable, which is the initial state, which we are using over here to then initialize the state variable. That is one thing that is happening in within initialize. And then you just need to set this to false, because this, we are pretty sure the game is just being started. And then when it comes to initializing the actions, this can be an array, numpy array, or just a list of the actions. Now please let me know if there is any confusion, anything that you don't understand.
So I had a question here, right? The init state in the deserialized function,
Yeah.
this init state is going to have 0, comma 0, right? In that
No.
array.
Whenever we talk about a state, we want to use a single integer, because that is just easier to keep track of. When we will implement algorithms, it will be easier to look up things, to map, other information to state. So that is why we have these two helper functions. So wherever we have rows and columns, we call this two state function, and then we convert it to a single integer. So
So
in
we
a state,
pass 0, comma 0 to this.
you need, like, when you are over here, right? If you look
Yes,
at this
line number
line,
30.
right?
Oh,
If you look at line 44, so what we're doing is, wherever we detect that, okay, the ball is here, in our case it will always be in 0 0, but suppose I change the layout and it is somewhere else. So whatever that row and column is, we convert that to a single integer using this state method, and then we store it over here. And because we have the init method now, we can now actually run this code. So I'm sorry, it will create an error because I need to But basically, if you run the code, then you can inspect what those variables are that we just said. Yep. So I'll go back and I will run the code in step 3, right? And then I'll run the code which is just below step 3. This will try to create a variable called foosball, and so it seems that there are no issues, no runtime issues. Code seems to be working perfectly. You can additionally print out other variables, like what exactly is there in init state. So you can do a print on init state, right? This is 0 right now because we are in row 0 and column 0, so the state will obviously be 0. But you can print something else like goal state, and this is 19, which makes sense because there are 20 cells and the goal state is in the last cell. Okay, so I hope this is making sense to everyone, and let me know if there is any confusion at all, because I keep repeating this, but this is like the backbone of all the work that we will do in the coming weeks. So we need to understand um, this code and how things are implemented and why they are implemented in that fashion. So need to have a really good grasp on that. And then if this is working, then let's move to step 4, where there is another little bit of implementation. So this method, everything about this method is already implemented. We wrote the code for init and deserialize, and there are some helper methods. But reset is really simple. If you look at the description, reset just with reset we want to bring the game back to its original state. And because the game has only one moving piece, uh, the player, or what you're calling the agent. So all we need to do is reset the position of that player to the original position, right? This is what you need to do. So state tracks the current state of the position. So suppose at some point the player is somewhere on the field and I call reset, I just want the player to be transported back to the original position. That is what you need to do here. And then there's another line where uh, you basically clear the reset the done flag. And the idea is that suppose you were playing a game and you reached one of the terminal states by either colliding with the defender or reaching the goalpost in whatever way. So if the done flag was somehow set, so we just want to ensure that it has been cleared again. It was already set to false in the init method, but reset could be called at any point. So maybe we have played the game for some time and maybe the done flag is false. Just set it back to maybe the done flag is true, so just set it back to false. So this is the second line is really uh, like one simple change, and this can just be implemented right now. We can set it to false right now, but the question is, how do we reset this, right? How do we set the state back to the original state?
We have the
We
init state,
haven't.
right? Self.init state.
Correct. So self dot init state. Right. This isn't a big change. There's no reason to like go to breakout rooms and ponder over it. But I really hope that everyone understands this. And if you're new to Python, then we keep using this self, which is like uh, the this or sort of a reference to the object. So you can create multiple instances of the same foosball class. So you want to be sure that we are implementing to the right instance whenever we access variables. We want to be sure that we are accessing variables which are part of a particular instance of a particular object of the class. So if you run this code and then run the next cell, right? So there's some output 0, And that is happening because when you're doing things in Jupyter Notebook, it will always print the output of the last line. So this line, if you look at reset, reset also returns the self dot state variable, and this is bound to be initial state because we are already setting that inside reset. So that is what you're getting here. So even if there is no print, uh, Jupyter Notebook will just print the output of the last line, right? Okay, so then let's move on to step 5, where it gets uh, interesting, because now we are sort of implementing the game, so to say. So we have all these methods already implemented, right? Init, set rewards, reset everything, and we want to go to this method, uh, which by the looks of it, you can see there are underscores in the beginning and underscores in the end of the function name. This is a convention to indicate to anyone who is going to use this class that this is meant to be used internally within the code of the class. So you generally don't want to access this from outside the class. But if you look at the definition for this function, it takes two parameters, state and action, and then it converts the state back to row and column, and then it is defining this sort of this is a dictionary that is mapping keys to values. So if you look at what the dictionary is doing, it's mapping north to -1 and 0 and east to 0 comma plus 1. What this is actually doing is it is mapping different actions which are just strings like north, east, west, or south, and it's mapping those to the change corresponding to them, the change in the position corresponding to those actions. So for example, north maps to -1 and 0 because the row changes by -1. The row number will reduce if you were to go north, right? So this is the change in the row, and the column remains the same, so that changes here. And then for east, obviously the row is going to be the same, the column changes by +1. So this is a dictionary that we just defined to help us calculate the new row numbers and new column numbers. And then so there were two parameters, right? So we used state over here, we converted state to row and column. And then what is happening here is that we are converting the action into a pair of integers, right? So this dictionary is being used to convert this action into a row delta and a column delta, and then we just add that row delta and the column delta to our existing row and column value, and that gives us back the new row and the new column, right? Now there are a few possibilities because there are restrictions on the rows and columns. So it's possible that the new row and the new column that have been computed in this way, they lie outside the bounds of the field, right? So if row number is below 0 or above 5, and if column number is below 0 or above 4, then that is a problem. So we want to deal with that. But what this function is really meant to do is that it will compute the next state for you, right? And how do we do that? We already have the updated row and column. So all we need to do is that we convert this information into a single integer that represents the state, right? So there is some sanity testing over here, and then you need to convert and of course return the new state, right? So there are two return statements, one over here and another one over here. This one is when if there is an invalid state, right? If you want to take an action that takes you outside the field, then obviously you don't actually execute that action. So keep that in mind. So if the action is such that the state transition is invalid, then there is no transition. So you should remain in the state in which you were already there. And if that is not the case, then you of course use this information over here to compute the new state. So let's take like a few moments, maybe 5 minutes or so, and implement this part.
So penalizing part is not part of this, right?
Sorry, penalizing.
Penalizing or calculating that. Okay.
Yeah, so that is done separately. So we will come to that, which is finding the reward for this transition from state to next state. But right now we just want to find out whether that transition is possible or not, and if that is possible, then what is the next state.
Yeah. So with same state, that means we had gone to some inner state that is implicit. Okay.
Right. Okay, so I'll try to show how to do this. So, like I said, this if condition is just checking if you happen to be in an invalid state after you make the move. So if you try to make the move, and you can test that with two-way comparison, something like this. So you can compare that if your new row is within the bounds or not, and if your new column is within the bounds or not, right? So we already had the rows and columns stored, and we just need to check if the new row and new column variables that we computed here, they are within the bounds or not. If they aren't, because there's a not upfront right here and upfront over here. So if this is not the case, then we just return the current state, right? That is what I discussed, that you cannot make the transition. That means you need to stay in the state and you return the current state. But if this is possible, if the transition is possible, then you just need to, you already have the new row and new column variables, convert that to a state variable, a single integer, and return that. And this is all that is needed over here. So
Alright.
yeah.
Uh, if that particular new row and new column is in opponent states or something, so whether we should return to that particular previous state, or uh, as it is a valid state, we should not return for us.
So if the new row and new column are opponent states, then you should make that transition because that corresponds to the game sort of ending, right?
Okay.
This is totally valid. But what should happen if you were already, like, the game has terminated because you collided and you ended up in an opponent state, and then you're trying to take an action? That is interesting, and we still don't, we aren't capturing that correctly over here right now, right?
Okay.
We will
Okay.
come to that a little bit later when we
Yeah.
have the full implementation in place, but that is a
Okay.
good question.
Yeah. Thanks. Yeah.
With this implementation, if you run the code, then we practically wanted to test if the new API is working. Seems to be working. We took actions. We passed it two variables: state 0 and action east. So if you imagine, you should go right, which will take you to state 1 because you'll still be in the same row but in column 1, which corresponds to state 1, and that is what gets printed over here, right? So hopefully this code is correct. Seems to be working, and that sort of brings us to this function which we were just discussing, that what happens, what about the reward corresponding to this transition. So that is what we have to implement over here, right? Now there are a few cases because there are four different possibilities in terms of reward. So it could either be that you are trying to make an invalid move, or an illegal, you're trying to end up in an illegal state, or you have entered a goal state, or you have run into an opponent, or you have just made a valid move, right? So there are four different possibilities. Again, let's take a little bit of time to sort of fill this up, but this should be straightforward, right? Because we have a dictionary that maps different possibilities to different numbers, and we just need to take out the value corresponding to the each of these cases, four cases, right? So let's quickly take some time, maybe next 3-4 minutes, to implement this. And one of the conditions is already implemented, so it should be very straightforward. So I'll try to copy paste from my solution.
One mark.
Okay, so this shouldn't be very difficult, but it's okay. Take your time to implement it. But I just want to explain the solution and then move on to the next step because we are like low on time. But over here, in the case where the next state and the state happen to be the same, and this condition has been put here because we know that in certain situations a real transition will not happen, so the next state and this current state will be the same. So that means this is happening when there's an outside, right? Or an attempted outside. So we just want to look up our dictionary, which is stored in self.rewards, and we want to get the entry corresponding to the move outside. This is what we are doing. This is the Python syntax for looking up a dictionary with a key. Uh, so this one over here is when you are performing an outside, and then similarly for goal, uh, then running into opponents was already there, and then we are just setting the reward for unmarked cells. Right? This is really straightforward. If you just understand the syntax, then there's no new logic over here. So just try to run this and run the next cell, right? Um, so the only output you see is corresponding to the last call, which is, so we are just arbitrarily checking. You can change these numbers over here and just see if this is possible, like if it's giving you the right results, right? So look at the sort of the map, the arena, and see what 10 and 11 correspond to, and then if 10 to 11 is a valid move or not. We are getting -1. We are not sure if this is because the move is valid, or whether it's because it's an outside. But you can like play with this, play with different parameters and see if this is working correctly or not. Seems to be working right now, right? So we are in the last 5 minutes. I don't want us to really try to implement the step method, which is like the soul of the whole class, because this is the API through which we will be interacting with the game most of the time. So what I want everyone to do is, we are largely familiar with what we are building. We sort of understand in which direction we are headed. In this method, if you look at the implementation, it's already telling you what we need to do in step function. So try to write this code. Of course, the solution is right in the next cell. Don't look at the solution. Don't do that. Try to write it yourself and run this cell over here and see if you are getting at least you shouldn't get any runtime errors or anything, right? And then there is the render method, which is already implemented. The code is somewhere outside. The link is over here. Just needs to be copy pasted over here, right? So after a step is implemented, then you just need to copy paste render below a step, and after that, that will finish your implementation, because render basically lets you print your environment in a user friendly way. And then you can create an object again, and then you can just call render just to see how the game looks like in the beginning. And this is how it is getting pretty printed, right? So these plus signs, they are just empty spaces where you can make a move. This is where the ball should be. This is where the goalpost should be, and this is how the player should be positioned. Render is mostly for debugging, so it will help us understand how the game is, transitioning from state to state. And then after that, in step 10, again, there is no implementation required. This is already a while loop that is written for you. And this is basically you playing the game. So just trying to understand, okay, we have implemented a bunch of logic in this game. Is the game working according to logic or not? So try running this, right? And it's possible that if you're writing the code on your own, then if you're writing the code on your own, then it's entirely possible that something goes wrong, right? And you get an error. So what I want to talk about in the last few minutes is how do you debug that code. And I just want to quickly show you at the bottom, right? So right, so let's write a function, write a very simple function that takes an input x, and then it just tries to raise that to power 2. So it's a very simple function, but if you run it with an input like 2, all seems fine, you get the right answer. But if you run it with something which doesn't make sense, like a string, right? So then you get an error. And in this case, the it makes sense. This is your own function, so it's really easy to pinpoint where the problem is. But how do you do this when with a larger, like the class we have implemented, if something is going wrong, then how do you debug it right inside Jupyter Notebook? And that is what I want to demonstrate. So what you could do is that wherever your code happens to be defined, which is this cell, you can go at the top of that cell and then add this at the top. Sorry, PDB. This is known as line magic, which are like special instructions for Jupyter. And this one happens to tell Jupyter Notebook that we need to enable debugging for this cell, right? So you can read more about how %PDB works in Jupyter, but like a quick uh, demo is what I want to show you. So after I have added PDB, I just want to rerun this cell. So now you see this message, or automatic PDB calling has been turned on. And now when you run into an error, so you still see the error. The difference is that now you are seeing an arrow over here, and there is a prompt over here, right, which is asking for some sort of an input. And this is pretty much like interacting with any other debug. So what you can do is you can use it to, for example, print variables. So if I want to see why, so this is crashing and it says unsupported operand types for power, or double asterisk, which is equivalent to power. It says str and end, but it's not clear to it's not clear to me. So I just want to see, because this is going, something is going on this line. So I want to see what X really is. Then I can just print X, and that immediately prints the variable. And now that makes sense to me, because it's a string. I can try doing things, right? So I just quickly, because I saw, okay, the input is n, so let me see why it's not working. So I tried raising it to power 2, and I saw that I get the same error. So whatever it is that you want to do, you can do this from this prompt. And then once you want to resume, because if you see this cell is still running, because there was a crash and the debugger has been called, so this prompt is still running. If you want to jump out of it, then you can just call continue, and that seems to have, because this eventually crashed, but that stopped the debugger, right? And there are other commands you might want to go up or down the stack trace, because you want to look at the function that maybe the function call at the beginning, or maybe the previous function call, whatever it is, you can do so. So there are commands to do that. uh, so but this is the idea, you can use PDB to debug stuff if you run into problems. Right. So what we want to do by Thursday is that we want to everyone to be able to implement up to step 7. That is all the implementation we need, and then be able to run step 9 and 10 correctly. So if you actually go to step 9, so we have in step 8, you already have sort of a full functional code, and you just need to copy render inside here, and then run step 9 and run step 10, and make sure you are able to interact with the environment and you're able to understand how things are happening. There are different commands you can see. There is R for resetting, X if you want to end the game and jump out, and then the normal command north, east, south, and west, they will work. They will, and at every step it will print you the arena or the field. Just play with it and really understand how the logic we have implemented that is working, because then after this we are going to think about how to do this algorithmically, right? So we'll interact with the environment algorithmically, and we will see that uh, how can we attain the goal. We want to score goals, how do we do that algorithmically? That is what we are going to do on Thursday and Friday. So and then there is a little bit of terminology sitting here right after step 12, which is incorrectly numbered as 12. It's actually step number 11. So there are a few things, but we'll discuss them on Thursday and Friday. is there any question at all about any of this?
So any hints on how are we solving this? Are we using dynamic programming or something? How are we?
Yeah, we will start with dynamic programming because when you look at the problem closely, you will see that it's a very, very simple problem where you just need to find the shortest path from the starting position to the end position. There are well-known algorithms like Dijkstra's is there. You can build your own dynamic programming approach uh, and use practically use any other shortest path algorithm. We are not
Yeah.
interested in those algorithms because a short while later we are going to come back and change the environment, so things become dynamic, the players start moving and there are different changes, and that is where you cannot use the shortest path approach. So
Yeah,
but
and
we will
also, yeah,
yeah,
we cannot calculate, just that because the rewards also will be,
right,
affected because
right,
if you hit
yes,
the opponent, yeah.
correct. So
Yeah.
because of that, so we do want to get started with dynamic programming approach because that sort of gives us the starting point, then we modify it to account for all these differences. So on Thursday, our first approach will be a dynamic programming based approach, but then we'll quickly move away from it and use a more learning based approach where we are actually interacting and understanding what the environment, how is it rewarding, how is it penalizing, what are the rules. So we don't want the algorithm to actually look inside our implementation and see what those rules are. We want the algorithm to learn that by interaction.
Okay.
Cool. That's all I had. Let me know if there are any questions. Otherwise, we meet on Thursday, and please mark that time on your calendar because now we're really getting started with the course because it's the core implementation that we are doing in the next 3 weeks.
Thanks, Farhan.
Okay, thank you all so much. See you on Thursday. Bye bye.